All right, let's just dive right into this explainer. Today, we're going to build our very own Data Detectives toolkit by mastering the concepts in this chapter on central tendency. Look, whether you're looking at grades, salaries, or rainfall, data is quite literally everywhere. And without the right tools, it's just a wall of meaningless numbers. Today, we're going to change that. Here's our roadmap for the chapter today. 1. Finding the center. 2. The arithmetic mean. 3. The mighty median. 4. Slicing data with quartiles and percentiles. 5. The popular mode. And finally, 6. Choosing the right average. Starting with Section 1. Finding the center. Summarizing the chaos. Look, in the real world, data rarely presents itself neatly, right? It's usually this vast, messy, chaotic thing that's incredibly hard to draw conclusions from just by eyeballing it. To put this into perspective, imagine a guy named Baiju. He's a farmer who grows food grains on just a single acre of land in Balapur village in Bihar. Now, suppose we want to figure out his economic standing compared to all 50 of the small farmers in his village. If we just dump a massive spreadsheet of 50 different land sizes onto a table, it's totally overwhelming. We literally can't evaluate Baiju's relative condition from that kind of chaos. So, to help Baiju figure out if he's doing above average or if he's doing better than half the village, we have to ask a really fundamental statistical question. How do we actually summarize all this wild data into just one representative number? Well, the answer lies in the core concept of this chapter, central tendency. Basically, this is just a numerical method used to summarize a whole set of data down to a single value. It's our way of finding that typical representative figure, what we casually call an average in our day-to-day lives. Moving on to Section 2, the arithmetic mean, the standard tool. All right, let's pull the very first tool out of our kit. The arithmetic mean is essentially a giant mathematical balancing act. It's definitely the most common measure out there. You simply add up all the values of your observations and divide by the total number of observations. Boom, you found your perfect balance point. Because it takes absolutely every single piece of data into account to find that exact center of gravity. Now, to actually calculate this thing, statisticians rely on a few different methods depending on just how messy or large the data is. We usually start with the basic direct method, which is exactly what we just talked about, summing it all up directly. But when you're dealing with overwhelmingly huge numbers, we have to step up to some advanced shortcuts like the assumed mean method and the step deviation method. So you might be wondering, why even use this assumed mean method instead of just adding everything up? Well, it literally saves massive amounts of time when you're dealing with giant numerical data sets. Instead of slogging through adding thousands of huge numbers, you just logically guess a central figure first based on your experience, and then you calculate how far all the other numbers deviate from that assumed center. It's a pretty brilliant time-saving trick, honestly. But here's the crucial takeaway for this section. The arithmetic mean has a fatal flaw. Because it inherently includes every single observation, any exceptionally large or small value on either end, what we call an outlier, can unfairly skew the entire average. Think about it. If just one farmer in Baiju's village suddenly buys 1,000 acres, the arithmetic mean for the village would absolutely skyrocket, making it look like everyone is super wealthy, which obviously just isn't true. There is one more really cool adaptation of the mean we should cover. Sometimes we need to assign more importance to specific items. Like if you're tracking price increases, you'd probably want to give more weight to the price of potatoes over mangoes, simply because potatoes take up a much larger chunk of a normal consumer's budget. Factoring in that relative importance gives us what's known as the weighted arithmetic mean. Section 3, the mighty median, the middleman. So if the mean is way too sensitive to those crazy outliers we just talked about, the median is our absolute best antidote. See, the median actually doesn't care about the total sum of the values at all. It's purely a positional thing. When you line up all your data from smallest to largest, the median sits exactly in the middle. Literally 50% of the data is above it and 50% is below it. It is the ultimate middleman. Let's look at an example using some factory worker wage data. We've got 160 workers in total here. By tracking the cumulative frequency to find the exact middle position, which would be our 80th worker, we can determine the median wage falls right into the 35 to 40 rupee bracket, specifically calculating out to 35 rupees and 83 paise. By focusing solely on that center spot, the median completely ignores those few folks who might be making insanely huge amounts at the top or very little at the bottom. Next up, Section 4, slicing data, quartiles and percentiles. Now, the median isn't just a standalone trick. It's actually part of a much larger family of statistical tools. If the median slices our data perfectly in half, we can also slice it into 4 equal parts using things called quartiles. The first quartile, or Q1, sits right at the 25% mark. The second quartile is just our old friend the median at 50%. And the third quartile, Q3, hits at 75%. This is super useful because Q1 and Q3 basically build a neat little fence around the central 50% of all our data. And we can zoom in even further with percentiles, dividing the entire distribution into 100 equal parts. This gives you exact relative positioning. So say you score in the 82nd percentile on a big management entrance exam. That actually doesn't mean you got 82% of the questions right. No, it means you know exactly where you stand against the competition. Your score was higher than 82% of the total candidates who took the test. Section 5, the popular mode, the crowd favorite. All right, time for our final and, frankly, most stylish tool in the kit. The word mode literally comes from the French phrase la mode. It represents the most fashionable value in your dataset, meaning it's just the value that gets repeated the highest number of times. It is the absolute crowd favorite. And unlike the mean or the median, a dataset can actually have no mode, one mode, or even multiple modes all at the same time. The mode is incredibly useful for qualitative data or when you're looking at distinct categories. Take a housing colony, for example, where we have plot sizes of 100, 200, and 300 square meters. If the 100 square meter plot has 200 units, vastly outnumbering the others, the mode instantly tells a builder that the 100 square meter plot is by far the most in-demand or typical choice for buyers. And finally, Section 6, choosing the right average. So we've got the mean, the median, and the mode. But how do they actually relate to each other? And which one should Baiju the farmer use to figure out a standing? Well, first, here's a really fascinating rule of thumb regarding their relative magnitude. Assuming your data isn't perfectly symmetrical, the median will almost always sit securely right between the arithmetic mean and the mode. It kind of acts as this anchor between the mathematical balancing act of the mean and the sheer popularity of the mode. Ultimately, choosing the right tool depends entirely on the nature of your data and what you're trying to figure out. You're going to want to use the arithmetic mean when your data is relatively balanced and you need to include every single observation. You'll switch to the median when you know your data is skewed by massive outliers, like huge wealth disparities in a village. And you definitely use the mode when you want to describe qualitative data or find out what has the maximum demand. And there you have it, your very own, fully complete Data Detectives Toolkit. By exploring the concepts in this chapter, we've unlocked a totally new way to read the world. So knowing what you now know about these 3 very different tools, ask yourself this. The next time a politician, a massive corporation, or a news article cites an average to try and make a point, which one are they really using to spin their story? The mean, the median, or the mode? Keep your eyes open, folks.